this is my screen, and open the Abaqus, and then I click with standard and explicit method. Okay, I'm going to walk you guys through. This is Abaqus modeling process. So this plate we have. This is a very thin plate. We assume this guy has this plane stress condition, and so I need to tell you guys the Abaqus does not have its own units, and so that means the modelers, the people, researchers must be very, very careful. And for our case, and the length, we are going to use meter. The young modelers, we are going to use Pascal, and also the traction, we are going to use Pascal. That means we are using the basic international units for this is model. So for parts, the first step is we define the part. So this is part one, and you can define it as a plate with a hole. I just write plate with a hole. And so we select the 2D planar, right? So the shell is a shell. That's shell. I told you this is a thin plate, and approximate size. And for our case, so the bottom line, this is a square. Okay, square. Then we just have a central hole here. So the size is equal to 0.5 meter. So it's okay. And we just write this is 5 meter. Okay, 5 meter, 0.5 meter is okay. And approximate size, we just want to use the board, just like a board. Board is 5 meter, and then we just draw a square, and whose size is 0.5 meter. It's okay. Then we continue, and then we'll be led to this is interface. Now we want to draw this is the circle first. And how to draw the circle? And we select this one. See, create arc, center, and to the endpoints. So we want to use this origin. See, look at it here. This origin. I press this one, right? So this here is a mouse. My mouse. I select this one, and then I select my first endpoint, which is on the horizontal line here. And then I select my second endpoint, which on the vertical line. Now, I have this arc. This arc is a 90-degree arc. And then I can select, see, look at it here, okay? Pick a central point for arc. Now I have finished. I just click this cross to cancel this procedure. And then I would suggest you guys to dimension it. Okay, dimension it now. I use this tool and dimension, and then I click the arc I just drew. So here, this is R equals 0.3. Now I can change. This is the radius of this arc, and for our case, the radius of the arc equals 0.125, and then I just 0.125. Then I just enter. Right. So look at this one. Here is say 0.13. It's okay. It's okay because now here it have the two significant digits. Now actually it is 0.125, and then we draw the bottom line, and we draw the straight line. Use this tool, create lines. So connect this point, and then go here, and you will see the H. There's a capital H here. Capital H means capital H means the horizontal, this line horizontal. That means this is a horizontal line. And now I want to dimension this line, and then I need to either press escape, ESC, right? And then I want to end dimension. Click this one here, because the total, the length from the left edge to the right edge equals 0.5. The radius of the arc equals 0.125. As a result, this line segment's length will be equal to 0.375. This is what I just entered, 0.375. Then enter. Now see this 0.38. Right? This is totally okay. Then I draw other lines. I draw from here. I draw a vertical line. And then I come here. Then I draw a horizontal line back to the left. And here, then I draw a line, vertical line here. Now I have finished drawing all these straight lines. I can either click escape, right? Or this is I can just click escape. Now I can dimension it. This one equals 0.5, right? Now this one equals 0.5 also. Yeah. So here you don't need to you don't need to dimension this one. Why? Because here this is constrained, right? You can just do it. The 0.35 is automatically, right? Okay, then click X. And then done. So see, the sketch is overdefined, then it can come back, okay? Now I just want to delete this one. Delete this. Here we go. Done. Okay, so this is deleted. So you should know that we cannot over constrain. This is the length. Why it is a problem? Because here is 0.5, and here is 0.125, and then you define this one. We know that from the perspective of a mechanical engineer. So this on this length, if we define this one, that means it is over constrained. So we are okay now. Let's press done. And sketch to the plane shell. I'm finished. Now you will see, this is my plate with the hole. Right? So this is my first step, create, and this is the plate with the hole. Then I need to define the materials. Double click it, material, and you can just define this one. I just use material one, and here click mechanical elastic, Young's modulus equals 203 gigapascal, 203, and gigapascal means 10 power 9, right? E9, right? And the Poisson's ratio 0.3. Now, this is isotropic material. This is we don't need to change anything here. And click OK. Now I have created a material. So you can see here is the number 1, and within this is parentheses following this material. Then next step, and go to sections. I need to create sections. Double click these sections. So section 1, I just define this one. Section 1, and solid, homogeneous. Then continue. And then just select this one, plane stress, plane strain thickness. Click this one, okay? Then we'll click OK. Now, after I create this section, I need to go back to the parts to assign the created section to the part I just created. And section assignment, double click it. So here, and it says that select the region to be assigned a section and create a sect. You can create a sect, but now I don't want to create a sect. So I'll just toggle this off. And then I select this one, okay? And then done. Now, which section you want to assign to this part? If you have multiple sections, you need to select. But for my case, we just created one section, section 1. So I just click OK. Now you can see this plate with a hole becomes green, right? So I would like to the next step. Okay, I would like to ask you guys to save Abaqus work. I just say plate with a hole. So always please remember, you need to keep saving your the work, right? So next step is assembly, and go to assembly. So double click. This is instances. Say create instances from parts. Which part? Plate with a hole. So I select a dependent one. You can just toggle this. You can select this one and select this one. It doesn't matter. Later, you mesh and you need to change. Okay, if the system say you need to change, use a dependent mesh, a dependent, and you just come back to click a dependent one. That's totally okay. I will from very beginning I will select a dependent, then click OK. Now I created assembly. Now next one is that I create steps. Right, let's create a step. Now I have an initial step. The Abaqus, the system, and gives a default initial step. And for our case, I want to do analysis. Double click steps. Then step 1, you can just name it. But for my case, I just say step 1. And what I'm going to do the static general analysis and press OK. And this NLGEOM means nonlinearity in geometry. And for I just want to click OK. Okay, or click on. You can use off if you are sure there is no large deformation, but sometimes we cannot make sure before we solve our problems. So I just for safety reason, I just select this turn this is a nonlinearity in geometry on, then click OK. Then I can apply boundary conditions, right? The boundary condition for our case, the boundary condition is that this is bottom edge is fixed. It's fixed. It's fixed in the y direction. It can move in the x direction, cannot move in the x direction. And similarly, for this is left edge, all the points can move in the y edge, can move in the y in one axis, but cannot move in the in x axis. So we can apply boundary conditions here. Apply boundary condition. So we will what the boundary condition will apply? The displacement, right? So continue, and we select this edge, and then done. So as I said, and they can move in U1, so U1 is relaxed. So U2 equals 0, cannot move in U2 direction. And click another one, boundary condition 2, displacement rotation, continue, and click here, right? The left edge, done. and uy equals 0, and can move in u2 direction and rotate about this z-axis, z direction, z-axis. Click OK. You can see. And then after you finish this one, right-click it and use the manager tool, and you can see. And so these two gates are defined from the step 1. This is not correct. It should be defined and from the initial step, and then move left. Then here will propagate. I will move left. Then I'm okay now. Then I apply the loads. I know that on the right edge, I apply the traction. The traction equals E multiplied by 10 power 9 Pascal. So I apply the load. What kind of load? Pressure, okay? And it is actually pressure is negative, in negative direction. So continue. So select the edge, and then done. Then specify the magnitude. The pressure is going to into the boundary, into this problem domain. But for our case, the traction is out from the problem domain to outside. So we should minus. There's a minus here, minus, and 1 E power 9. The unit is Pascal, and then we click OK. As you can see, this is our traction. We save it. Now, next step is that we need to mesh this problem. Mesh this problem. And how to mesh it? Now, this time I want to show you guys and how to partition. We want to mesh using the quadrilaterals. And so here I want to partition this domain using this point, the center, the midpoint of this arc, and this is the top right corner. Where I draw a straight line to divide this problem domain into 2 quadrilaterals. I'm going to show you how to do it. And first, I need to define the partition. Define the partition and then partition it. And here, look at I use this tool, create partition. So create a partition. See here. So this is I can say I use the data. So we use this one. Okay. Select midpoint, the datum point, midpoint. What midpoint? Select edge to partition. So here, right? And select point on edge. On this edge, on center. Partition define complete, and then create a partition. You can see this point is highlighted. So select midpoint. When it's midpoint, I have formed the midpoint of this arc, right? Now I have defined, and this is the partition. I just create a partition. Now I'm okay now. Now I want to create a partition. Right? Create partition. So it's a partition. This is here's a partition cell. Define partition plane. Then I create a partition. Then I just edge. Then I place a face here, and use. Now as I showed you guys, I want to divide this problem domain into 2 quadrilateral by connecting. This is the center point of this arc, and this is the top right edge, the top right corner. So I say user shortest the path between 2 points. I select the starter point. This is my starter point. And select end point. I select this end point. Now partition definition complete. Then create a partition. Right? So you can see clearly, and here, and this is a line here. Now this is the one quadrilateral, and so this is another quadrilateral. So some students might ask, Dr. Ma, why you want to divide this problem domain into two quadrilaterals. I want to tell you for this problem, for this is arc, for this is here's arc. I want to for this arc, because this curve, I want to use finer mesh, right? And I want to use the finer mesh here and a quarter mesh here. How can I do that? I need to use I need to plant the seeds with bias. I'm going to show you guys. Okay, now I have two quadrilaterals, and then I'm going to go here. I finished this already. I'm going here mesh. Right? If you want to mesh something, and you need to plant, we say plant, quotation mark, plant, seeds, and plant seeds on these edges, right? I seed. So suppose for our case, I want to have 40 seeds here on this edge, 40 seeds here, 40 seeds here, and 40 seeds here, and 40 seeds here, and 40 seeds on this edge, and 40 seeds on this edge. No, see, select the edge to be assigned local seeds. Here, one, how many? Can you look at this one? Basic method by size, by number. I will use by number, right? See the bias, none, single, double. What is the bias? Bias means that if you say no bias, that means so all this edge will be divided evenly by the number of seeds, right? If you have this is a bias from single, and you want to have the number of the light segment will be divided into the number you just specified. However, but on one end it is a finer, another end it is harder. I'm going to show you guys. So for this arc and this one, I just use without a bias. I use this option of without a bias. So how many number of elements? How many elements I have? I want to use 40. Okay, 40. Click this one. So this is a 40. I have 40 evenly distributed these elements, these seeds, and then select the region to be assigned local seeds. I select this one, and then done. And I'll also use 40, non-bias, by number, and create. Right? And then on this one, I select this one, done. 40, non-bias, by number. This one, done. By number, none, 40, okay. Right? So because I'm going to use quadrilateral, so the number of elements on this edge and the number of elements on this edge must be the same, because you are drawing the lines. So one point here has a corresponding point here. Then on this, as I said, for this is arc. Near the arc, I want to have much finer mesh. Far away from the arc, I want to have quarter mesh. So then I want to see this edge. Okay, this edge. Now, still by number, I want 40, but this time I want to have single. So single bias. You can see this is the. You can see if I select non-bias, so this is arrow here. If I select a single bias, and here's arrow here, right? So this arrow, the point, the end of the light segment that this is arrow points to, will have finer mesh. As a result, for this case, if we do not flip this arrow and hit it on this end, and we will have a finer mesh. On this end, and we will have quarter mesh. and which is contrary to our intention. So we need to flip this one. Okay, I just flip. So this is arrow points to this end, which means that on this end, I will have finer mesh. On the other end, I will have a quarter mesh. And you can see. Okay? You can see clearly, right? So here is finer, and here is a quarter. And do the same thing for this one. By number, edge, 40. Okay, this is a ratio. Okay, the ratio means that the length of here divided by the length of this element. This is the element size equals 5. Right. So if we look at it here, this arrow points to this end. So this is what we want, and so we have this is okay. Right. So you can see, and then on this end, done. And by number, single, still the bias ratio will still use 5, okay? And however, for these three guys, for 3 lines, and you can change the bias ratio. That depends on your preference. As I told you guys, bias ratio is a ratio. Bias ratio is a ratio of the longest element and to the length of the shortest element. So for instance, for here, the distance, the length of this one divided by length of this equals 5, right? And then we click OK. So you can see here is finer. Now we're done. We have place seeds on all edges. We're done. Now next step here, assign mesh control. And because we have 2 quadrilaterals, and we need to select them simultaneously using the Shift key. Shift key. Shift, click this one, and then click this one, then done. So, and we want to mesh control. We use quadrilateral, right? And we use a structure. Structure means they go 1 point, draw here to the corresponding points. And the quadrilateral structured, then click OK. So now this is assign mesh control. Then we use this one, assign element type. And then because we have 2 quadrilaterals, we should use the Shift key. Select this one, done. And here standard linear, but for family, right? Because our problem is plane stress, so we need to select plane stress here. And here quadrilateral, reduce the integration, and you don't need to change all these options. They press OK. Now select the region to assign element type. We're done already. And then the last step for meshing is click this one, mesh part instance. Okay to mesh the part instance? I say yes. Now I say this is my mesh. Right? Questions so far? Okay, yeah, I'm walking sketch through. You cannot ask me questions now. Okay, guys, let's save it. Now I have finished everything. What's the next step? Next step is that I create a job. I will click it, and the job 1 I name it as plate with hole. Then click continue. Then OK. Then I can just submit it. Submit. It is running now. So I can check the status, monitor. I'll check the status. Okay, successfully, because this is a linear elastic problem, so it can be solved very quickly. Then I have to finish, complete it, and right-click it, and then results, click the results, and then so I select this ODB file. ODB file is a result file for the Abaqus. So I can press this one to see the deformation, right? So you can see this contour plot, and for this is a vertices. I can see other variables. Go to results here and fill the output, and so you can see reaction force. This is stress, vertices stress. You can see other stress also. Let's see S11. S11 means the SXA, sigma XX. So this is sigma XX. Now we want to. I can see the this is the animation. This animation is too quickly. I can just let it go slower. Then I just do it again. Now you may not see this guy's deformation because the deformation scale factor equals 1. Okay, and how can I exaggerate the deformation? I'm going to show you guys. Go to the option here, common. Go here, deformation scale factor. Scale factor 1. Okay, and I just use 50. Oh geez, 50 is too much. 50 is too much. Lose time. 10. Okay. Both. Okay, I can see the both. This is the original one. This is my deformed one. Then some students might ask, I don't want to see these elements here. How to do that? So here, this exterior edges. If you select exterior edges, you will see these elements. If you don't want to see these elements, you can just select this one, no edges. Right? Yeah, this is pretty much, and how it goes now. Okay, so yeah. Then let me show you guys, if you want to see define a parse, I'm going to show you on how to define the parse. How to define a parse. Here, define a parse. The parse 1. Edge list, continue, and to bottom line. Okay, I will edge list for using feature. Now this time I want to have these elements back. Exterior edges. Now I want to here. Okay, so I want to exaggerate it. And then I can do this. Select edges to be inserted into the path. See, I can select all these bottom edge. Now, done. Okay. Now go to the XY, the data, and select the path. Continue. This is path what I just defined. And what I want to see S11 and plot. So this is S11 along the bottom edge. I can save as save as what? XY data 1. And done. Okay. After I finish this one, here, X1 data 1, I can output what I just created and to the Excel file. So go in here, plug in an Abaqus, these tools and Excel utilities. And which one you want to output? I select XY data -1, that one I just created. From Abaqus CAE to Excel. Okay. Okay, my Excel is open. Now I can want to stop